let us discuss a new concept, that is upper bound, okay, of a given set. So suppose we have a set S. So when we say M is upper bound of set S, if all elements of S are less than or equal to M, then okay, of S, then we can say M is upper bound of S. For example, suppose set A is equal to 2, 3, 4. Set A has how many elements? Only 3 elements. So clearly all elements of A getting are less than or equal to 4 for all x belongs to A. All elements of A are either equal or less than 4. So we can declare 4 is upper bound of set A. Therefore, 4 is an upper bound of set A. Getting? So you can write the same thing for 5 also. All elements of A are less than or equal to 5 also. So 5 is also an upper bound. 6 is also an upper bound. Upper bound is not unique. Getting? If there exists upper bound, so it can be many upper bounds. Or you can say 4 also. 4 is also upper bound. See, 2 is less than or equal to 4. 3 is less than or equal to 4. 4 is less than or equal to. Equality is also possible there. Getting? So 4 is also, 4 can be an upper bound. 4.5 can be an upper bound. Getting? So many upper bounds are there. So in this way we can find upper bound of a given set. Okay. Let us discuss second example. Suppose B is equal to open interval 3 comma 6. What is a given set? B. B is an interval here. Getting? Here we had taken only 3 elements, but here suppose 3, 4, 5, 6. This interval we have. So clearly x less than or equal to 7 for all x belongs to B. So all elements of B are less than or equal to 7. So we can declare 7 also. 7 is an upper bound of set B. You can write the same thing for 8 also, 9 also. All these are upper bounds of set B. Getting? So make a screenshot of it, then we will go for next definition. So let us discuss this next definition, that is when we say a set is bounded above. If the given set has upper bound, then we can say the set is bounded above. Okay, let us discuss few examples so that concept can be, we can clear that concept. So we have set A, okay. So set A has only 4 elements, 1, 2, 3, 4, 5, 6, 7, okay. So see, 2 is there, 2 element, 4 and 5 is also there included, 6 is also there included. So this given set has only 4 elements. So clearly all elements of A are less than or equal to 7. Getting? All elements of A. So see, all elements are less than or equal to 7. So therefore we can declare 7 is an upper bound. You can write for 8 also. Even you can write for 6 also. 6 is also an upper bound. Since all elements are less than or equal to 6, equality is also there. So you can take 6 also. Getting? So all these are upper bounds. But we are interested to know it has upper bound or not. So therefore I will mention here 7 is an upper bound of A. So given set A has upper bound, so that's why we can declare A is bounded above. They implies A is bounded above. Getting? Therefore given set A is bounded above. So let us discuss this second example. So in second example, B is a interval they are given. Getting? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is open interval 0, 10. All elements they have given between 0 and 10. So clearly x less than or equal to 10 for all x belongs to B. All elements, okay, of set B are either equal to 10 or less than 10. Equality is not possible since this is an open interval. Open interval does not contain its boundary points, getting endpoints. So therefore all elements are clearly less than 10. So therefore we can declare 10 is upper bound of set B. So implies 10 is an upper bound of set B. Of set B. So what it means? It means set B has upper bound. So therefore set B is bounded above. So implies B is bounded above. So this is very important thing we have got here. Let us go for the next set C. C is set of natural numbers. You are familiar with that. Natural numbers means 1, 2, 3, 4 and so on. How many natural numbers are there? Infinite natural numbers are there. So there is no last point. There is no end point. Get it? So 1, 2, 3, 4 in this way. If you draw a line, it will be like this. First natural number is 1, second is 2, next is 3, next is 4, next is 5, next is 6 and yeah, 7, 8, 9, 10. It will not stop anywhere. So that means we cannot find any number such that all natural numbers will be less than that. If I say all natural numbers are less than 100, then 101 is there. If I say all natural numbers are less than 1000, then 1001 is there. That means we cannot find an upper bound for n. Okay, so therefore C has no any upper bound. Getting? So A has no any upper bound. So therefore we can declare C is not bounded above. So therefore set C is not bounded above. So these three examples we have discussed. See, let us discuss few more examples. Okay, so before that make a screenshot of it, then we will go further. So let us discuss few examples. That means some sets are given here and we have to check whether those sets are bounded above or not. If they are bounded above, then we have to find their upper bounds. Okay, so what is the first set? Set A is equal to 3, 2, minus 1, 5, 0. It has only 5 elements. Getting? I will show you here. See, 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2. Okay, so 3. First element is 3, second is 2, next is minus 1, getting? Next is 5 and next is 0. See, all these elements are less than or equal to 5 or less than or equal to 6 also, even you can write. Here x less than or equal to 5 for all x belongs to A. So therefore we can declare 5 is an upper bound of A. So A has upper bound, so therefore we can declare A is bounded above. So therefore set A is bounded above. Okay, so in this way we finish first example. Let us discuss next example. See, in this second example, set B is given and what have they given? It contains natural numbers, all natural numbers which are less than or equal to 4. So you know that natural number starts at 1. So natural numbers are 1, 2, 3, 4, 5. But see, we cannot go for 5 since they are clearly mentioned our natural number should be less than or equal to 4. So it has only 4 natural numbers. So clearly I can write clearly n less than or equal to 4 for all n belongs to B, or x also we can write. Getting? So therefore we can say all numbers of B, getting, less than or equal to 4. So 4 is upper bound and set B is bounded above. So therefore set B is bounded above and 4 is its upper bound. You can write same thing for 5 also. 5 is also upper bound, 6 is also upper bound. Many upper bounds are possible there. But the important thing is, yes, it has upper bound. So that's why I say it is bounded above. Okay. So let us discuss this third set. Okay, see, what have they given? It contains all integers. You know, integers 0, 1, 2, 3, 4 and here minus 1, minus 2, minus 3 and so on. So all these are integers. Getting? And they have added one condition here, that square of those integers should be less than 5. So let us find the elements, actual elements of this set C. See, 0 is an integer. 0 is an integer and square of 0 is 0 less than 5. So 0 lies in this set. I will write the set simultaneously. 0, 1 is an integer and square of 1 is 1. So that's why it lies in this set, less than 5. 2, 2 is integer, 2 square is 4 and 4 is less than 5. So that's why 2 is also member of this set. 3 is an integer, 3 square is 9. 9 is not less than or equal less than 5. So that's why 3 cannot we can add in this set. What about minus 1? Minus 1 is an integer. Square of minus 1 is 1. So less than 5. So that's why we can add minus 1 also. Minus 2 is integer. Minus 2 square is 4. 4 is less than 5. So it is member of this set. Minus 3 square is 9. So that's why it is not less than 5. So we cannot add minus 3 there. So that means the basic given set C has only 5 elements. 0, 1, 2 and minus 1, minus 2. Getting? So clearly x less than or equal to 2 for all x belongs to set C. Getting? So all elements of this set are less than or equal to 2. Equality is also there, so we can write 2. So therefore 2 is upper bound and the given set we can declare it is a bounded set. So therefore C is bounded above. Getting? It's bounded above and 2 is its upper bound. Okay, so in this way we solve this example. Upper bound, so not bounded, it's upper bound. Make a screenshot of it, then we will go further. Let us discuss this next set D. Okay, so they have given the set with a condition 2x minus 1 is greater than 11. So we need to solve this condition first, then we can easily decide the given set is bounded above or not. So let us simplify it further. X belongs to R. What will I do? I will shift 1 on that side. So that's why 2x greater than 1 plus 11, that is 12. Then we will divide both sides by 2. So therefore x belongs to R. What will we get here? X greater than 6. Getting? So we can consider all real numbers which are greater than 6. That means if I draw diagram, it will be like this: 0, 1, 2, 3, 4, 5, 6, 7, 8. Getting? All real numbers which are greater than 6. Greater than 6, that means it can be anything. Can be 100, can be 1000, can be 1 lakh. Getting? So there is no any upper bound. So it will not terminate anywhere. Getting? So therefore D has no any upper bound. Getting? No any upper bound. So therefore what can we declare? Therefore D is not bounded above. It is not bounded above. So therefore given set D is not bounded above. Okay, so make a screenshot of it, then we will go further. So let us discuss this next example. So in this example, n is a natural number and the set is collection of points which are in a form 1 by n. Okay, so that means if I put, natural number starts from 1, 2, 3, 4. So we can put values of n is equal to 1, 2, 3, 4. If I put n is equal to 1, 1 upon 1 is 1. If I put n is equal to 2, 1 by 2. N is equal to 3, 1 by 3, 1 by 4 and so on. Getting? So if I plot those points here, first point is 1. Getting? Next point is 1 by 2, half. Next point is 1 by 3, it will be here, right? Next point is 1 by 4, it will be here. So that means next obviously 1 by 5, 1 by 6, 1 by 7, 1 by 8. So those will move towards 0. They cannot go beyond 0, since now on this side of 0 we will have a negative numbers and these numbers cannot be negative. So that's why we can easily see as you increase the value of n, those numbers are moving towards 0. Getting? So obviously these numbers are less than or equal to 1. What will be the largest number? 1, and all remaining numbers will be less than or equal to 1. So here I can write here x less than or equal to 1 for all x belongs to set E. So therefore E is bounded above. E is bounded above and 1 is its upper bound. Upper bound. Okay, you can say 2 is also upper bound, 3 is also upper bound, but 1 is also an upper bound. See, please make a screenshot of it. One more example we will discuss. See, in this set, what we have, see, numbers are in the form 1 minus 1 raised to n. n is a natural number. So you know natural numbers means 1, 2, 3, 4, 5, 6. So these numbers will be, natural numbers will be either even or odd. Get it? So if n is odd, what will happen? Minus 1 raised to odd number is minus 1. So minus minus plus, and we will have 2. And if n is even, minus 1 raised to even number is 1. So 1 minus 1 is 0. So that means the given set has only two elements, 0 and 2. If n is even, we will have 0. If n is odd, we will have 2. So it has only two elements. So 0, 1 and 2. Getting? So 0 and 2. Only two elements are there. So clearly I can mention clearly x less than or equal to 2 for all x belongs to f. So therefore we can declare, therefore f is bounded above and 2 is its upper bound. 2 is its upper bound. Okay, so in this way we completed this example. Make a screenshot of it. After that we will stop. Thank you. Bye bye.